Hello, this is Richard Boyd. I'm doing my little video for my next big thing submission here on July 3rd. I want to talk about something I think is incredibly important in digital twins and the adoption of AI within the Department of Defense and within the modeling and simulation community. So the topic uh, of my talk will be about sovereign AI and architectures and data sovereignty and something I call AI contagion and how to implement it in a way where you have something I called an epistemic airlock that anytime AI touches a system, touches any information and does an output, you can actually quarantine that until it's been validated and verified, V, something we understand in this community, before it comes back into the corpus of information for whatever organization. That is something we're seeing a lot in organizations in commercial and government communities and systems, and it's a really big problem that can lead to something called model collapse. So in my talk, and this is just a brief overview, I'm going to go over things like what is AI contagion, how does it happen, how do you contain it, how can you architecturally design for it, things like again about model collapse um, and methods we can use to solve that. Data sovereignty means that you're not uploading your data to software as a service environments, even if they promise, like Microsoft does and so many others, that they're not going to encrypt it, keep it from you, or more, or even more, use it in their training their AI system, their AI models. It's really difficult for us to even find out if that's true or not, and we're seeing a variety of lawsuits and issues already popping up with all the major providers where they've been caught doing exactly that. So I don't think in government we should be in a position of trusting that people are going to be careful with data. Um, so, having stuff that's in your cloud, that's under your control, that's transparent, where you can visibly see, almost like an OV6C, and that's something I'll show you live in this presentation, an OV6C of how the whole provenance chain of how bits of information entered the organization, who challenged it, who championed it, how that stuff gets combined. And certainly when any form of AI touches it and produces a new output, it has to go in that quarantine, what I call an epistemic airlock. Um, and again, there's lots of great models, open source even, that government can be taking advantage of. The DARPA Global Data Plane, Berkeley's Terraswarm project, I'll talk about that briefly, and just the architectures that we learned from that and how those can be implemented alongside and together with MCP architectures, digital twins, all sorts of things where you can be confident of the data in every step of the way, and again ensure that you don't have contagion from hallucination or erroneous output. We'll talk about the structural fix, and again these are all open source components that can be combined by anybody, and I think it's critical that anyone that's contemplating digital twins or AI systems are aware that there is this architectural possibility that's not being implemented widely to protect our data and our systems from model collapse and AI contagion. So I'll go through that entire thing. I can do it certainly in 15 minutes or so and give the actual, uh, describe the problem, but also show exactly what the solution is and how to implement it. So I think this will be valuable for the ITSEC audience. And I look forward to seeing you guys at ITSEC for my 23rd ITSEC. Cheers.